Hello, we are going to review for the Chapter 2 test. So this document should be in Google Classroom, so make sure that you have it in Notability and you're doing it along with me. So let's start with problems 1 and 2. Now it says to graph each relation. I'm only going to graph number 2, just because I'm not too concerned about graphing these points. State the domain and range will do for each, and is it a function will do for each. So let's start with number 2. It says to graph it. Now to graph a relation like this, you just plot the points. So we have a point at -5, 0. We have a point at -3, 1. We have a point at -1, 2. We have a point at -3, 3. And we have a point at -5, 4. If we list the domain for this, the domain is -1, -3, and -5. If there are any repeats in the domain, you don't write it. The range for this is 0, 1, 2. That sure didn't look like that. 3, 4. Is this one a function? Well, since we had some repeats on our x's, our -5 repeated, and so did our -3, that would be no, it is not a function. If we applied the vertical line test, here is a spot where the vertical line hits it twice. Here is a spot where a vertical line hits it twice. So because of that, we could say, no, it is not a function by looking at the x's, or we could look at the actual drawing itself. Now, number 1, I'm not going to graph it, but I'm going to do everything else, okay? So the domain would be -4, -2, 0, 2, 4, just listing out the x's. The range would be -81, 21, 51, 33, and -9. Since the x's are all different, yes, it would be a function. Okay? Let's take a look at 3 through 6. It says find the values of the functions for the given elements of the domain. Let's start with number 3. It says that f of x is 2x squared minus 3x plus 5. F of -3, you're just going to take out all of the original x's, and you're going to input -3. So that's going to go right there and right there. Now, as you do this, you have to follow order of operations, so make sure you don't do anything funky here. So this is 2 times 9 plus 9 plus 5. And then that is going to be 32. Let's now do number 4. For number 4, the f of x they're using is 11x cubed minus x plus 1. And we are inputting 5. So wherever we see the x's, you are going to place a 5 there. Now you're going to do 5 cubed, which is 125. So that's 11 times 125. Which is 1375, take away 5 plus 1, which is 1371. So remember, you're just inputting things, okay? Let's do number 5. Number 5, f of x is 7 minus x squared. This time we are inputting 3.7. So we have to do 3.7 squared. So that's 7 minus 13.69, which is -6.69. And then finally, let's do number 6. F of x is x minus 3x squared. We are inputting 0. So it's going to be 0 minus 3 times 0 squared, which is 0 minus 0 or 0. So when they say to find the values of a function for the given elements of the domain, they're just telling you different inputs that you are plugging into the function. Be very mindful of your order of operations, and you should be fine. For numbers 7 through 10, they have asked us to graph them. So let's take a look at number 7. Now 7 is an inequality. I'm going to write it here so then we can kind of zoom in. I don't like the fact that the y is on this right side. So for an inequality, let's turn it, and we turn the symbol with it, and then divide by 3. Now that's a linear inequality, so we're going to graph the line with the slope of negative 2/3 and the y-intercept. I said slope of negative 2/3, I'm sorry, I wrote a b. With the y-intercept of 5/3. We are going, because of this symbol, we are going to make it a solid line, and we are going to shade above it. Greater than goes above it. Okay? So let's start at 5/3. Now 5/3 is like 1.7-ish, so it's about right here. And then we're going to count down 3, staying in that same location, and then over to the right. Down 2, I'm sorry, and over to the right 3. It should be roughly right there. And then let's connect that with a line. And we make that line solid. And we want to shade everything that is above that line. Okay, greater than is above. So I kind of try to find the y-axis, and then that kind of gives me the sense of where to shade. So that is number 7. Let's take a look at number 8. Number 8 is just a standard line. I like doing lines either using the intercepts or using slope y-intercept. Let's just move the 2 over. And let's make my intercept chart, my 0, 0 chart. If I plug in 0 where the x is, that's what this is saying. If I plug the 0 right here, I get negative y equals negative 2, so that's 2. If I plug 0 in for y, that puts a 0 right here, and so I get 4x equals negative 2, so x equals negative 1/2. So I found my y-intercept is at 2, and my x-intercept is at negative 1/2. So let's plug negative 1/2 as my y-intercept. My x-intercept. 2 is my y-intercept. And then let's go ahead and graph that. There's no shading on that one because there's no inequality. It's just a line. It's the equal to, which gives you the line. Let's do number 9. 9 is just an equal to. It's going to give us a line. This is a vertical line, a solid vertical line when x equals negative 4. So that's all there is to that one. So remember, y equals a number is a horizontal line. X equals a number is a vertical line. Let's look at number 10. 10 is a good old just standard line again. Let me write it down. Y equals 2x minus 5. That is a perfect slope-intercept form. Our slope is 2. So make that 2 over 1 so we know where to go. Our y-intercept is negative 5. So we're going to start on the y-axis at -5, count up 2 to the right one, up 2 to the right one, up 2 to the right one, many times as you want. And then go ahead and draw your line. And it's just a standard line. So there are 4 different graphs, 1 inequality, and 3 just linear graphs. Let's look at 11 through 14. Let's write 11 down. Y is less than or equal to 10. Now, if it only has a y in it, it is going to be horizontal. We know that it's less than, so it's going to be under it, and it's going to be a solid line. So at 10, just at the top of my graph, we're going to have a solid line, and then we're going to shade everything below it. Now let's do number 12. We have x is greater than 6. That's going to be a vertical line. It's going to be dashed. Now for x's, we have to go left to right. The x's get bigger as we go to the right. So we're going to shade to the right, okay? So let's go here and make a dashed line when x equals 6. And then let's shade to the right of that. Okay, so those are only x on only y's. Let's look at 13. Let's solve this one for y. Let me zoom in here. Let's get the y alone. So let's add an 8x to both sides. So it'll be positive when it goes over to the other side. Then let's divide by 4. And now we can graph it. Our slope is 2. Our y-intercept is 8. Because of this symbol, we're going to shade above. And we are going to have a solid line. So let's make a y-intercept at 8. Go up 2 over 1. And then I'm going to just continue the pattern the opposite direction so it kind of fills up my graph paper. I'm going to make my line solid. And then I'm going to shade above that. So see the little y-axis right there? That's above it. So that is number 13. Let's look at number 14. Now 14, could you please make sure these little bars, make them straight up and down. We'll call that an absolute value bar, okay? So let me write that down. So we're going to get f of x is the absolute value of 3x plus 3. Now, I hope you know by now that the absolute value is going to make a v. Let's plug in -1, 0, and +1 to see where that v goes. Now, the reason I chose that is because if you set 3x equal to 0, you get 0. So 0 is still the point of our graph. And so if you plug in -1, you get 6. If you plug in 0, you get 3. If you plug in 1, you get 6. If you chose the right vertex or center, you should see this repeated y value because of the symmetry of an absolute value. Now, it's just a absolute value. It's a solid line making that v. So at -1, go up 6. At 0, go up to 3. At 1, go up to 6 and make your v. I'm sorry, my v is so squiggly. Okay, so that is number 14. Let's look at number 15. It's an absolute value, so it's going to be a V. Let me write it down here so we can kind of zoom in. So it's going to be a V. It's going to be a V shape. We're going to make it dashed because of the inequality, and we're going to shade under the V because it's less than. Now, where is the V going? Well, if we set x minus 1 equals 0, the V starts at 1. So for an absolute value, you definitely want to plug in 3 points. The center, one above it, and one below it. So 0 is below it, and 2 is above it. If I plug in 1, I get 0. When I plug in 2, I get 4. When I plug in 0, I get 4. See that symmetry that I was talking about in that last problem? So the last absolute value. So let's make our dashed V. So at 0, we're at 4. At 1, we're at 0. At 2, we're at 4. So our dashed V looks like that. Now we want to shade under that. So under it, just find the y-axis where it's under it. So it's this section of the V. So we are below the V, okay? So that's 15. Let's take a look at 16. 16 is just a line. Let's write it in y equals mx plus b form. Our slope is 3. Our y-intercept is 1. So start at 1. Count up 3 over 1, up 3 over 1, as many times as you want. You can even go down 3 over 1 a few times. Connect your line. It's just a line, so make it a solid line. And there is number 16. Now let's look at 17. Let me write it down here. I'm going to write that in y equals mx plus b form. The reason I put the 0 out there, because it doesn't have a 0 when you see it here, is because I can find that m and b a little quicker. This is my m. This is my b. It's just a standard line, so let's just draw it. We're going to start at 0. Count down 1 over 2, down 1 over 2 as many times as you want. You can even go the opposite way if you want. I am such a bad line drawer. The more points I have to connect, it just helps me. So there is 17. Let's take a look at 18. 18 is just a standard line. Y equals 3/5 x minus 4. Our m is 3/5. Our b is -4. So we're going to start here at -4. We're going to count up 3 over 5. Up 3 over 5. We're going to connect it. And then we get our line. So there's 18. Now for problems 19 through 24, they ask us to find the slope through the pair of points. I'm going to do 19 through 22, and then I'll give you the answers for the last ones, okay? But let's write down the formula. The formula we're going to use each time is y2 minus y1 over x2 minus x1. So let's look at 19. Our points are 8, -4. Let's label that as x1, y1. Our points, second point is 6, 1. Let's label that x2, y2. Let's plug that into the formula. So it's going to be 1 minus -4, make that a plus 4, so you're subtracting the second value. So when you subtract a negative, it becomes a positive. And then subtract the y, so it would be the x's. So it's going to be 6 minus 8. So that's 5 over negative 2. It can't reduce, but it's customary to put the negative on the top with the 5, or just write it out in front. Let's do 20. Write down your points. Label them x1, y1, and x2, y2. Let's plug them into the formula. So we get, 5 minus 5 over 4 minus a negative 2 is 4 plus 2. That's 0 over 6, or 0. Now, if they ask us to describe that line, this line is a horizontal line. Now, I'm going to give you the answers to 21, 23, and 24. Give me 1 second to figure those out and give you those answers. So the answer to 21 is 13. We're going to do 22. The answer to 23 is 3 over 5. And I'm trying to write little. My 3's don't look like 3's very much. And then 24, the answer is 1/3. So let's do 22. So write down your points. Label them, x1, y1, x2, y2, and you get negative 3 minus 5 over 4 minus 4, which is negative 8 over 0. Now, like 20, it was a horizontal line with slope of 0. Here, this is an undefined slope. When the denominator is 0, that is an undefined value. This technically would be a vertical line, and that will always happen if your lines line up vertically. So there's some slope ones. Let's take a look. That's so strange. We kind of got a little 1/3 stuck up on the screen. There we go. Let's take a look now at writing an equation of a line in slope-intercept form satisfying the conditions given. Now, the formulas that are going to be helpful here are y equals mx plus b, and also y minus y1 equals m times x minus x1. So those are the formulas you should memorize, okay? Now, when do you use which? Well, I'll go through the process and tell you. Now, problem 25 is very nice. They said that the m was negative 5 and the b was 11. So you just plop them into this. And so it's going to be y equals negative 5x plus 11. Bam, you're done. Perfect. Now, 26 is a perfect example of using this formula because they give you a point, a slope, and a point. So for 26, we want to put it into this formula. So it's going to be y minus 15 equals m. Let's actually put the number there, 2/3, times x minus a negative 6. See this negative 6 here? So that's going to make it a plus 6. Now they said to put it in slope-intercept form, so let's do a little bit of rearranging. Distribute the 2/3. We get 2/3 x plus. Now how do you multiply 2/3? Times 6. Just do 2 times 6 is 12. 12 divided by 3 is 4. Now I'm going to add 15 to both sides. I get y equals 2/3 x plus 19. And we're done with 26. Now let's look at 27. Now the problem with 27 is they did not tell us the slope. Either equation that I've written in blue on the side, you have to have the slope. So the first thing I want you to do for 27 is find that slope. So if we label x1, y1 and x2, y2, let's do our slope. So our slope is going to be negative 8 minus 7 over 7 plus 3. So that's going to be negative 15 over 10, which reduces to be negative 3 over 2, okay? So now let's take the point that I've labeled x1, y1. It really doesn't matter which, but let's take this point and this slope and use that formula. Okay, so we're going to do y minus y1, or y1 is the 7 you see right there, equals our m, which is right here, negative 3/2, times x minus our x1, which was right here. So that's going to become plus 3. So we get y minus 7 equals negative 3/2 x minus 9/2. 7 is 14/2, so if we add 14/2 to 9/2, that's negative. That's going to be positive 5/2. And that's unfortunately is gross. That's what you're going to get. For 28, they told us the b right here. The y-intercept is negative 4. That's our b. But they did not tell us our slope. But they kind of told us 2 points. The x-intercept is the point 90. The y-intercept is the point 0, negative 4. So let's use those to find the slope. Well, the slope is going to be y2 minus y1 over x2 minus x1, which is negative 4 over 9, negative 9, which is 4/9. As soon as we have the slope and the y-intercept, the m and the b, we can just use this formula. So that's why these two formulas are really important. And so we would get y equals 4/9 x, our slope, times x, plus our b, which is a minus 4. So that one is that. 29. 29 is pretty similar to 27 to 28. So for time purposes here, let me just give you the answer to 29 is y equals negative 1/2 x. But I do want to do 30 and 31. So I'm going to cut and paste these down here so we have a little more room. So I am concerned here. Let's put it on a new page. So let's look at 30 and 31. Let me start out with 30. It says that I am parallel to the equation of the line that's given, and I'm passing through negative 2, 8. Parallel, you might recall, means that we have the same slope of whatever they gave us, okay? So let's take this equation and do a little rearranging. We get negative y equals negative 6x plus 7. Divide off the 1. Here's our slope. So the slope we have is 6. The point we're going to use is negative 2, 8. That is a perfect example of using y minus y1 equals m times x minus x1. So let's put those values in. So it's going to be y minus 8 equals 6 times x plus 2. And then just distribute the 6. So y minus 8 equals 6x plus 12. Add 8 to both sides, and we got it. And so that is number 30. Now let's do 31. Now the thing that they said differently in 31 is they used the word perpendicular. Remember, perpendicular, the the slopes are opposite signs and reciprocals. So what does that mean? Well, we need to figure out what the slope is for this. So let's do a little bit of rearranging. So we're going to subtract an x from both sides and divide by 3. So the slope they showed us was -1/3. So the slope I am going to use is the opposite sign of that, so positive, and then the reciprocal of that, so 3/1, or 3. Now, they said that we want to pass through the point 5, 2. So it's another perfect example of using the equation y minus y1 equals m times x minus x1. So let's put the 3 in and the 5, 2 in. So our x1 is 2, our slope is 3, our y1 is 2, our x1 is 5. And then just distribute the 3 and add 2. If I add 2 to 15, negative 15, I get negative 13. So there's that one, okay? So this is very similar to what you're going to see on the test. So if you study this, you're going to be ready for the test. So I hope this helps. Thank you so much for watching, and you have a good day.